Right, so now we're going to be using recursive and explicit formula for geometric sequences. So same type of thing, the recursive formula, we're going to be using that more so for when we're finding lower numbered terms, whereas the explicit formula we can use to find any term of the sequence. Now remember, geometric sequence are when we're multiplying by the same number every time. And to distinguish between arithmetic sequences and geometric sequences, we actually use a different format. In arithmetic sequences, if you remember, we used function notation. In geometric sequences, we're going to use sequence notation. So for a recursive formula for a geometric sequence, we write lowercase a sub 1, which means this is not an exponent of 1. It's written a little bit below the 1, but that basically what that means is just the first term of the sequence. So it's the first term, which is exactly how we start with the arithmetic sequence, only we use a of 1, capital A of 1. So it's a little different, but it's in the same format. And then we write a, lowercase a sub n is equal to lowercase a sub n minus 1 times, so like back in arithmetic sequences, we did a of n is equal to a of n minus 1 plus your common difference. Well, since geometric sequences are in terms of multiplication, we're going to do times our common ratio. So this is the recursive formula for a geometric sequence. The explicit formula would be a lowercase a sub n is equal to your first term, which I'm going to write as a sub 1, times your common ratio. Now this is a little tricky, to the n minus 1 power. Whereas over in arithmetic sequence we multiplied by n minus 1. Here we're going to raise our common ratio to the n minus 1 power, because now this is very similar to the format of y is equal to a times b to the x power, except it's a sub 1 times r to the n minus 1 power. And then if maybe you drew the connection for arithmetic sequences is basically the same as y is equal to b plus mx or mx plus b. These are very similar to linear equations and exponential equations that we've been dealing with. They just use different variables. So it's in the same format, it's just different variables here. And that's okay. So if you know how to write an exponential equation, you should be okay with writing the explicit formula for a sequence of a geometric sequence. All right, so numbers 1 through 3, we want to write the recursive formula and explicit formula. Let's start with the recursive formula. So for number 1, and we're going to label our work to say, hey, we're doing the recursive formula right now. So number 1, we would write a sub 1 is equal to the first term of your sequence, which is 500, and then semicolon, a sub n is equal to a sub n minus 1 times your common ratio. Now to find my common ratio, I do my second term divided by my first term, which is going to give you a 1/5. So times a 1/5. Now in number 2, same thing. We're going to do the recursive formula, rewrite it as a sub 1 is equal to, and then we state our first term of our sequence, which is 5, and then semicolon, a sub n is equal to a sub n minus 1 times your common ratio, which in this case we're multiplying by 3 every time. And then number 3, we do a sub 1 is equal to your first term, which in this case is 40, semicolon, a sub n is equal to a sub n minus 1 times your common ratio. To go from a 40 to a 10, that's a 1/4. So we're multiplying by 1/4 every time. So this is these are your recursive formulas. Now we're going to do the explicit formula. I'm going to label this E for the explicit formula. My explicit formula for number 1 would be a sub n is equal to my first term, which was 500, times 1/5 to the n minus 1 power. Number 2, same type of thing here. I'm going to do a sub n is equal to my first term of 5 times 3 to the n minus 1 power. And then lastly, number 3, I'm going to do a sub n is equal to my first term, which is 40, times 1/4 to the n minus 1 power. Now, in the next question, it says we want to find the 6th term of our sequence for number 1. Now, this is going to be easy because we're going to use the recursive formula. We're just going to continue this pattern, which is multiplying by 1/5 or dividing by 5 is the same thing. So if I do 500 divided by 5, I get the 2nd term of my sequence, then the 3rd term, then the 4th term. So I'm going to do 4 divided by 5 to get my 5th term, which that's going to be a 4/5. And then I'm going to multiply by 1/5 here because this is, it's easier to multiply a fraction by 1/5. Doing 4/5 times a 1/5, we get a 4/25 for our 6th term. All right, but in the next one, find the 25th term for number 2 here. I'm not going to want to do the pattern 25 times. So here's how we find the 25th term. We would put 25 in for n. And all this a sub 25 means is that we're finding the 25th term. So you don't even have to worry about the a sub 25. That really means nothing. We're going to follow the order of operations. We're going to do the 25 minus 1 first. So I really have 5 times 3 to the 24th power. And now I can just type this into my calculator. 5 times 3 to the 24th power gives us, and this is going to be a really long, we're going to approximate here. We're going to do 1.41 times 10 to the 12th power. That's in scientific notation, which you might have learned last year, but we're just going to write our answer like that. All right. Now, numbers 3 and 4 state to tell whether the sequence is geometric or arithmetic, justify our answer, and write the recursive and explicit formula to represent the situation. Now, in number 3, we're multiplying by -2 every time. So this is geometric. It says to justify why it's geometric, and that's because we have a common ratio, not a common difference. And our common ratio is -2. Now we write the recursive formula, which would be lowercase a sub 1 is equal to my first term, which is 6, semicolon, lowercase a sub n is equal to a sub n minus 1 times my common ratio of -2. My explicit formula would be a sub n is equal to my first term of 6, and since my common ratio is -2, it absolutely needs to go in parentheses, and it will be raised to the n minus 1 power. The reason why this -2 needs to go into parentheses is because if you end up with an even exponent, it's actually going to turn into a positive number. So we need to keep that -2 in parentheses because the negative also needs to be raised to the exponent. But that's it for number 3. Number 4, this is arithmetic because we're adding 0.5 every time. So it's arithmetic. It says to justify our answer. So we're going to say because it has a common difference, not a common ratio, a common difference here. That's what makes it arithmetic. And it's a common difference of 0.5. we're going to write the recursive formula, which hopefully you remember. We start with capital A of n. Sorry, capital A of 1, I apologize, is equal to your first term, which in this case is 3, semicolon, capital A of n is equal to A of n minus 1 plus your common difference, which is 0.5. Your explicit formula for an arithmetic sequence would be capital A of n is equal to your first term of 3 plus your common difference times n minus 1. That n minus 1 is not an exponent in an arithmetic sequence. It is an exponent in a geometric sequence. Now, number 5 says find the 17th term for the sequence listed in number 3. So since this is a higher term, we are going to just use the explicit formula. So I'm going to put 17 in for the n, and that a sub 17, all that means is that we're finding the 17th term. So I really just need to focus on the right side of this equation, which is a 6 times a negative 2, and a 17 minus 1 gives us a 16th power. Now again, this is very important because when I put this in my calculator, I need to put parentheses around the negative 2. This negative 2 is being raised to the 16th power, so we should get a positive answer. So I'm going to type in 6 times parentheses, negative 2, close your parentheses, caret, which is the exponent, to the 16th power, and I get 393,216. Now it says in number 6 we want to find the 50th term for number 4. So again, we're going to use the explicit formula, but for the arithmetic sequence here, I'm going to put 50 in for n. Remember that a of 50 just means that we're finding the 50th term. That's just function notation. It doesn't mean anything more than that. So we just want to focus on the right side here. We're going to do the 50 minus the 1 first. So I have a 3 times a 0.5 times a 49. Sorry, 3 plus a 0.5 times a 49. Following the order of operations, I'm going to do the 0.5 times the 49, which I get a 24.5. And now I can simplify this to a 27.5. That's my 50th term in the sequence to number 4. All right, that brings us to the end of this lesson.